agentic systems, if you don't have the reasoning models, in most cases, not always, but in most cases, you, the developer, would have to basically come up with a flow chart yourself. These are the different things that we have to do to solve this problem. Then write the code that controls the execution from scratch. You don't need to do that anymore. You can use a tool like LangChain. But one of the issues is that these are not, they are often not, it's not always, but often they're not general purpose. You might have to create a different agentic system for each problem or domain.
Before we kick it off, I did want to remind everybody, so thank you for joining the product management exercises community sessions. We've got a couple of cohorts I want to let you know about. We've got our AI agent cohort, second cohort learning program starting next week, actually. It runs for 4 workshops, each 90 minutes, and you'll learn how to build AI agents in a few multi-agent systems and deploy them. Pretty neat stuff. We'd love to have you. It's taught by Corey Hill, an expert AI leader at Amazon. And then later on in April, we've got our AI product manager learning program. It's our 10th cohort. It's taught by Kai from Uber and Corey again from Amazon, excuse me. Very exciting program. You could learn how to become an AI product manager or incorporate AI into your products. That is a 5-week intensive program, and we would love to have you there as well. I'm going to put the links in the chat. It'll also be in LinkedIn if you're watching there. Would be very excited to have you. And then without further ado, I want to introduce Don Rosenthal. He was a group product manager at Google. He's worked at Meta. He's worked at NASA. Very impressive resume. He's here to talk to us about AI reasoning models for product managers. So without further ado, Don, take it over. And thank you and welcome.
Good. And thank you very much. And it sounds like an exciting lineup that you've got going on. I might sign up for a couple of those. Sounds like fun. Anyway, I'm really excited to be meeting with you all today. Reasoning models are a big piece of the puzzle for what the AI world has been dreaming about since, even before I was a starry-eyed undergraduate, and that's getting computers to actually think. So Robert Heinlein, a well-known, all right, hang on, there we go. Robert Heinlein, well-known science fiction author, once said, any sufficiently advanced technology is indistinguishable from magic. And the AI world is moving so incredibly fast, it's hard to keep up. And each new advance seems like more magic, and it's very hard to know what even to pay attention to. So my goal today in talking with you folks is to help you understand well, what exactly do we mean by reasoning models? What are they? How do they work? And no math, I promise. It'll be an intuitive introduction, very painless, and how to use them, which is pretty important. And we're all product managers. What are the opportunities that they provide to us as PMs and for our users and for our companies? And I'll also go through some actual use cases, some reasoning output for work that I've done recently. And there's a lot of buzzwords floating around, and some of them are used kind of loosely. And you may be scratching your head during this presentation and say, wait, isn't this exactly what somebody told me about agents? So time permitting, I'd like to get into that and differentiate the two types of technologies and actually show how they can really be productive working together. So if we start in the early prehistory of large language models, and that's in AI years, that's all the way back to Q4 2024, maybe 3 months ago. The large language models that we were using at that time were pretty amazing at what they did. Pretty magical, as you might say. But they had one major flaw, and that was they would start a response, and this is how all LLMs work, even the reasoning models. They'd start a response, they generate it sequentially, one word, actually one token at a time, but a word is a pretty good proxy for tokens. We'll just talk about words, one word at a time from start to finish. And because of the way LLMs work in this way, they're capable only of system one thinking. Now, don't panic. Next slide is going to tell you what system one thinking is. Daniel Kahneman, a very interesting writer. He was actually an economist. He published a few years ago, he published a book called Thinking Fast and Slow. And if you've read his book, you might remember that he talks about system one and system two thinking. And all of the previous generations of LLMs simulated what he termed um, system one thinking. And if you haven't read the book, I'm going to summarize the important points right now. System one thinking is the fast, almost instantaneous, rote thinking that we do in our minds when we are recognizing a familiar face, when we're absentmindedly reading a billboard, when we commute to work and we get to work and we realize actually we don't remember the ride. We weren't looking for exits or things like that. We were on auto drive, or tying your shoelaces or playing a video game that you've played 1,000 times before. You're not thinking about the controller. You're just automatically doing the right thing to do what you do and need to do in the game. That's system one thinking. And why were large language models only capable of system one thinking? Like I said, at the very core, LLMs then and now still really only try to predict the next word in a sequence. And a quick shout out to Matthew Berman, who's one of the people that I rely on YouTube to keep me up to date. He's very good about whenever there's a new advance, making an easy to understand video about it. Or anytime a new model drops, he runs it through a series of test prompts. And one of the test prompts that he used to use, doesn't use anymore because of reasoning models, was the very, very simple prompt to the chatbot, to the LLM. How many words are in your answer to this prompt? And they routinely fail. And you think, boy, this is a really, really simple question. Why can't you get it right? Well, first, let's think about how we do it in our heads. Oh, okay, how many words are there in your answer to this question? And you kind of in your head say, okay, there are n words or blank words in this answer. Then you go back and count the number of words in that sentence. Okay, there are blank words. Okay, seven words. You place that number, you place the blank with seven, and your answer is there's 7 words in this answer. LLMs can't do that. They can't do that very simple thing that's second nature to our. They'll go through it word by word. They'll say there are, and next it needs to output the number, but it doesn't have any idea yet what else it's going to say because it's only doing this one word at a time. So it doesn't know how many words will be appended. So what does it do? It comes up with, a guess, a reasonable seeming number, and they typically get it wrong. Now, those of you who like to do puzzles are probably thinking, okay, sure, but that's just one example. What if they structured it so way that they left the blank until the very last word? Well, not only is it true that system one, that LLMs you predict just one word at a time, but they were single pass system one thinkings. I mean, all system one is single pass. They could not, like humans, leave the number blank and go back and fill it in later. They just had to do it sequentially, one token, one word at a time. But system two thinking, that allows you to incorporate analysis. Oh yeah, let's see, there's a way I can do this. I can put a blank in and come back like task decomposition. You've got one large task that you have to accomplish. You break it into subtasks. Plan construction. Okay, I've got all these subtasks. How am I going to execute each of them, and how am I going to tie the results from each of those subtasks together? A review of the current status. How's this going? Is it going the way I want? Did I make any mistakes? If I did, they can go back and correct. You can go back and correct. Even restart. even say, okay, I'm not sure what the best way is to solve this. I want to try a couple of different approaches and see which one gets me the best answer. That's system two, or slow thinking. And as Kahneman said in the book, and remember when I'm reading this, that at that point, he wasn't talking about AI, he was talking about human cognition. He said the automatic operations of system one generate surprisingly complex patterns of ideas. That's true. Remember in the early days of ChatGPT, there was this famous thing going around the internet where somebody said, explain to me how I would remove a peanut butter sandwich from the input port of a VCR, but using phrasing of the Bible. And it was able to do that, generating a really complex pattern of ideas, one word at a time. But only system two can construct thoughts in an orderly series of steps. And the really important point here is orderly series of steps. And that's what these LLMs, as wonderful and fun and interesting as they were, that's what they've been missing all this time, the ability to think about thinking. So how did we solve that problem? And I just want to say that all the images that I'm using in this presentation were generated by the just dropped 2 days ago GPT 4.0 in chat mode. I didn't have to go to an image setup. Just in chat mode, you could say, hey, I'm doing this presentation. Give me some illustrations. So we haven't completely figured it out yet. We haven't completely solved it, but it does work really, really well in a limited number of domains. It's something, the key to all of this was something called chain of thought reasoning. That's not a new technology. It was first published just a couple of years after LLMs were defined, just after transformers were defined. It's sometimes called test time compute, which is a pretty confusing name because it's actually inference time compute. You are giving it a query, and at inference time to answer that query, it's doing a bunch of computations, doing some thinking. But the name was coined by researchers who train LLMs and test them, train and test, train and test, train and test. They don't have a phase called inference. That's just for us users after they're done with the research. So it makes sense to them. That's what it's called. But you can use inference time compute, which makes more sense, and people will still understand what you're talking about. I'm not going to read all of this, but I just want to show you that when this concept was first published, it was pretty messy. It was pretty difficult. It was pretty awkward to try and use it. It was all through prompt engineering. So in chain of thought prompting, which was the only way you could do it at that point, you'd give it examples before you gave it the question you wanted to answer. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each has 3 tennis balls. How many tennis balls does he have? In your prompt, you would show an answer. Roger started with 2 cans of tennis balls. It's stake 5 plus 6 is 11. The answer is 11. And you do this one or more times, one or more examples. And then you'd finally ask it the question. Cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? And the hope was that it would follow the examples that you had presented it with. And instead of just probabilistically putting some number out there, it would actually go through and say, okay, there were 23 apples originally. They used 20 to make lunch. 23 minus 20 equals 3, et cetera, et cetera. The answer is 9. Lo and behold, this actually really worked, which was a surprising result at that point. Now, fortunately, these types of examples are built in during the fine tuning, during the training of the model. We don't have to do anything special. We don't have to craft these messy, complicated prompts in order to do this. You ask, you send a query to the model, and it goes into reasoning mode. One way to think about this is that reasoning models are essentially creating flowcharts. That's the planning part, right? You're putting together a plan, and then they execute them. So it might say, okay, in order to solve this problem, let's decompose the task. Okay, I've got these 5 tasks. I'll put them together in this order. I have to make some decisions, et cetera, et cetera. Let me review that. Yeah, that looks like that plan will work. Let's start executing it. So they execute each of the steps one by one. So how do we use them today? Because they're out there today. They've been out for a while, actually. And you use them, just you don't use them any differently like you would use any other language model or any other chatbot if you're using it in that mode. The only thing that you might have to do for some of these models is turn on reasoning mode, so it's not using the compute. Um, you don't have to have it on reasoning mode all the time, so that if you ask it simple questions, it doesn't turn a lot of inference time trying to answer it. Turn on reasoning mode. There's no additional coding. There's no fine tuning. There's no complex prompt engineering. You just use it. But like always, whenever you're using these models, take time to craft and test your system prompt if it's an API-based use, programmatic use in your product, or if you're just talking to it using your chatbot, be explicit and unambiguous in your user query. So it's just this added new feature that you have for these models. You just use them the same way that you always used to use them, but now they can do system two thinking. They can take complex problems, decompose them, and uh, uh, um, execute the plans, review them, and then come back to you with a finished product. Okay, all presentations should have the so what question. This is interesting, Don. Good. I can win some trivia contests with the information. Why should we bother? Why should we pay attention to this? The most important thing that this opens us up for us now is the ability to solve much more complex problems with AI, with large language models, than we could before. Anything that required multi-step planning, and you had to do this ahead of time, you could build a agentic architecture and do it that way. And that still is a very reasonable thing to do in a lot of cases. But now, in certain domains, it can actually do all of that for you, the task decomposition, building the flowchart, et cetera. That since we can solve more complex problems, we can build products now that have far more value for our users. And for us as PMs, um, this is going to be, and for some, if you work in the appropriate domains, it already is like a superpower. All of a sudden, you can solve a lot more complicated problems. You can get it to tell you why it's giving you a certain response, etc. So, not only can we use them to power amazing new products, but we can use them in our day-to-day work as PMs. And I'll show you an example later, like writing a spec. I really deeply hope that I never again have to write a single PRDs solely on my own, that I've got an assistant that can do a lot of the legwork. I can come up with some of the ideas and tell it to, here's how you write it up. All right. What about cost? It's a new technology. It's probably going to cost a lot more, right? Well, the inference cost for LLM-based products is coming down drastically every single year by a very large factor, sometimes as much as 10x. And inference cost could be charged back to your users. It's the time on the computers that you rent from your cloud provider. You can charge it back to the users if you can afford to increase your subscription cost a little bit. But that's nothing new, because these types of inference costs are just like any cost to serve for any cloud-based product we've been using uh, for a while now. So we can bake that in if we have to. So the cost to serve is not a big deal. But what about the development costs? Important question. Um, These technologies are non-deterministic. They're based on probabilities. What does that mean? That means that you're going to have to do a lot of trial and error work during early development. There's a lot of experimentation. We're not to call it research. There's a lot of experimentation. You've got some ideas. We can try this. We can try that. You try them all. You see which one works best. Hopefully, one of them worked well. It's not your standard requirements code test ship model. It's not a situation where after you've built it, um, you can predict every answer that the system is going to give you. And if it doesn't give you that answer, it's a bug. That's not the world we're in anymore. So yes, there likely will be some development time, especially if some more. There'll be likely to be lengthy additions to your development time. Um, and it's important to be aware of that from the very beginning. It does affect the time to market and time to the ROI. Your first one is always going to be the hardest one. It gets easier after that. But you always got to start at the beginning. Experience starts when you begin. So, but we as PAMs can manage that. We've got to put together a reasonable business plan to convince leadership that this is a really worthwhile thing to do. The most important thing is so that everybody understands in advance, this could take longer than you're used to. This might have more dev costs than you're used to. Make sure that everybody's on board because one thing leadership really hates is surprises, especially when the surprises involve hits to the schedule or the budget. But you can also show them that the capabilities of these products, the things that you can provide your users, will be huge differentiators for the products. And you know, the thing that's in our favor as PMs is that right now leadership has all of these AI forcing functions in their heads constantly, every day. I do a lot of consulting, and it's not uncommon that my clients or proto clients would come to me and say, "Hey, Don, we got to do AI. Everybody does AI. We got to do AI. We don't know how to do AI. Come help us do AI." A lot of our leadership is still in that situation. So if we, as product managers, do our due diligence, we present a well-crafted, defensible concept for an actual AI project, they will listen because they're really hoping that somebody in the organization is going to come up with an AI-based project that's a real differentiator, that's reasonable to do, et cetera, et cetera. So what are the things that we can use this for? Currently, these reasoning models are most valuable in applications where there is a problem or a question that's got a clear yes or no, right or wrong answer. And that's no surprise, logic-based coding, especially, and a lot of the STEM applications. And the reason for this is not because of a limitation of the technology, not a limitation of the model, but it's kind of a limitation of us as human beings trying to train them. Because in these domains, there's an objectively correct answer for every question you might throw at it. So I'll go in a little bit more depth about this so you understand why this is an issue. Typically, we use fine tuning for we use reinforcement learning for fine tuning. And reinforcement learning, you probably have heard a lot about. You may know what it's about, but it's not a new concept either. It didn't start in technology. It's a cognition and psychology problem. It goes all the way back to Pavlov. It's like training a dog with treats. Basically, you want to train the model to show its work, and you give it rewards when it's correct. How do you give a computer a reward? You can't give it a dog bone. You give it a numerical reward, and you tell it its job is to amass the largest amount of reward that it can. To go a little bit deeper, there's two ways that we can do this. You can give a reward that's based only on whether or not the final answer is right or wrong. You're asking it to show its work, and you look at that because that's useful to know in debugging. But if it gets the right answer, it gets a reward. If it doesn't get the reward. This is something that's pretty easy for the research team, but it's very slow, and the outcome, the product, the model that you train can be less reliable. If you remember back a couple of years ago, Google's DeepMind AlphaGo, the Go playing system that was able to beat the top Go players in the entire world, and even come up with new strategies that had not occurred in any human playing games previously. The way they trained this was they just taught the system the rules for playing Go, and let it play tens of millions, I think even hundreds of millions games against itself. If it won the game, it got a reward. If it lost, it didn't. So it took forever for it to figure out on its own how to play a good game of Go. But it worked because they had the resources to run the reinforcement learning for that long. The other way to do it is by giving partial credit. Remember, we're asking it to show its work. And you can say, just like we did back in math class in grade school, the teacher would say, show your work. You'd show your work, and you would get the first three steps right, and then you did something wrong, so you got the wrong answer. But you got a smaller reward. You got some points for the first three steps that were correct. This is much more work for the research team, but it's quite a bit faster. None of this is fast, but it's faster, and it also gives pretty reliable results. And remember, I said that this reasoning models work really well in domains where there's an objectively right answer. This is why you got to be able to figure out, do I give a reward for this answer or not? Well, in a math question, logic question, etc., that's a lot easier to do than in creative writing, say. Um, that that's why they're good at STEM. You're able to do self-supervised learning. You can tell if the answer is right without human annotation, which means it's a lot quicker. If you're asking it to write a program, does the program run? But we're beginning to validate. This is really interesting because we're thinking, oh no, we got to figure out how to do this in some places where rewards are given out subjectively. We don't know how to do that. Research is beginning to show that even just training the reasoning models on the STEM domains actually, in fact, builds models that generalize to more subjective domains like creative writing. All right, that was a ton of background. I hope it was useful. Please ask any and all questions you might have because it's good to really understand at this level how this all works. But let's look at some things that these systems can do. So let's say you want to prototype some cool new product idea, which we do a lot. But your coding chops like me are a little bit rusty. There's this new term that's going around called vibe coding. Basically, all that is working with a large language model as an assistant to do the coding. And you tell it what you want, you ask it to write some code. In the previous generations of language models, because they didn't plan ahead, once they started, they couldn't go back and revise. You almost always wound up with really buggy code. And after a few turns of conversation, when you're trying to do the debugging, the model would get so lost, so far out in left field that you say, let's not continue this conversation. You stop, you create a new conversation from scratch to try and debug it. It was laborious, it was useful, and it did for some people, especially like me, if your coding skills are rusty, it actually saved you a lot of time, but it was painful. But now you can start by just explaining the problem, and then you ask it to write a spec, and then you start a new conversation with the spec and tell it to code to this spec. Now it's doing all of the spade work, right? You are just explaining the requirements, et cetera, which we're good at, and why and how the user wants to use that, and it goes through and does all these other steps for you. So I haven't commercially coded in years, although I'm still a hobbyist, but I've been able to build proofs of concept and demos quickly and easily in frameworks and language that I have never used. And if this was just a project I'm doing for myself, but not for a client, I'd probably take the time and read the manuals. But it's something that's on a deadline. I didn't have time to do that, and this was able to help me with it. So just to give you an example, and to show that I'm a really bad typist. I know how to spell, but I'm a bad typist. Just to show that these things are clever enough they can work through typos. Here's an actual prompt that I gave to Claude for a recent project. Can you help me with generating specs for code? I got a small section that I'd like to refactor, blah, 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 blah. But it involves some coding areas I don't have much experience in. So I can't guide you on that, right? So could you put together a spec first, or could we put together a spec to help me through the dev? Um, and this was its response. Oh, that's a great idea. Blah 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 blah. The thing that I was most excited about this and that I wanted to show you was um, to help you create a specification document. I'd like to understand more about your specific section, your specific situation. It's asking clarifying questions, which was pretty astonishing. Remember in PM 101 in the textbook that we had on page 130, paragraph 2, it was all about asking clarifying questions. It's PM 101 to ask clarifying questions. This asks clarifying questions. The old versions would not have done anything like that. They would have just started to write the spec. You can read through this. These will all be in the slide deck. You can read through the details if you want, but later. But basically, it's telling me here are the things I'd like to know a little bit more about. Once I have this, here are the sections of the spec that I'll put together. And so I answered its questions and said, it can be written in Python. Here's the high-level answer of a real function. Let's implement it in steps. We'll worry about performance last. And then, because I thought this was really cool, I wanted to make sure it continued to ask clarifying questions. I specifically asked it, do you have any more questions? And it came up, this is not the spec, this is the plan that it built to write the spec. And again, I'm not going to go through all the details, but this was a multi-page plan, and these are the different sections that it put together for the plan. And you can see it's thinking to itself, the human is asking for help creating a specification document, et cetera, et cetera. Here's the goal of the project. Implementation approach, let's use 4 different phases. Here are the technical constraints. And, again, for each of these sections and subsections, I've written a lot of text. And this is what the spec is going to cover. Then it gave me a chance to review the plan. Hey, is the plan to your liking? Is this complete enough? And I told it yes, and it actually wrote. It was a 5 or 6 page spec. Again, these are all just the subheadings, but functional overview, implementation phases, technical requirements, et cetera, et cetera, et cetera. So very quickly, very easily, got from explaining a problem that I wanted to solve and code to getting a spec, getting a plan, getting a spec, and then getting the code. Within one afternoon, literally in hours, from start to finish, I had the new code up and running within my existing demo just by iterating a few times, getting the spec where I wanted it, and then here's the spec, write the code to it, and it included things like I said that I knew about, like Docker, but I'd never coded. I never had to create a Docker container, etc. It did all that, including Python environment details. Um, but that's okay. Maybe that's kind of cheating because I was using the reasoning model to help it do something for me. I wasn't building a product with it. I was building a demo for it. This was for my use. It was a single time thing. But I wanted to show this as an illustration of what's possible and to make it clear, you can package this up so that you have these exact steps for a product that you are building for other people to use. All the different conversational terms. Hey, this is what I want to do. Oh, okay. Ask it well, here's a system prompt that you might use. Okay, you're a coding assistant. Start by asking the user about their goals and follow up with as many clarifying questions as needed. Generate a spec, have them review the spec, then help the user set up the runtime environment, generating the code. So this is how you would take the experience that I showed you and put it into a general purpose product, that you could then let other people use if they wanted to have the system write some code for you. For example, this is just clarifying the example to let you see that using the reasoning models in chatbot mode is not all that different from being able to build a product for it. And in fact, if you wanted a proof of concept for your leadership and for your developers, you could just keep the work products of your chatbot session and say, hey, it can do this. Yes, I'm doing it in this way, but let's figure out how to do this through APIs. But it has the capability to do this. Here's your proof of concept. That template, which I showed for coding, carries into lots of other complex use cases. A research assistant. I use this lately for a customer for prioritizing what insurance types were most important for their MVP. It did all the research, it did all the data analysis, generated tables, wrote a full 6-page report. And this was something that I did in chatbot mode, but it could be a general purpose product. Business process automation, which today is pretty much template based and is very limited. But you can have it use these same steps, ask what they need, ask what the user needs, ask clarifying conversations, write up something that defines it, get them to review it, and then build the code that does the process automation. And even something for help desk, which is actually usable by the end users because it's able to determine what questions to ask and on its own how to diagnose issues and use that rather than following pre-built handcrafted scripts or whatever your next big project might be. Take some time seriously, think about whether you can create this amazing magical product using these reasonable numbers models. Okay, let me check if there's still time, and looks like there is. I'm going to check with Ida to see if we do. Yes, all right. So I know that you folks are going to have a multi-week session on building agents. Very cool. Like I said, I might sign up for that myself. But with all the hype these days, people aren't very clear about definitions of their terms. And so this might seem just like what somebody was explaining to you about how agents work. Being of the agents is overloaded, and you can use it for almost anything, even if it's got no AI in it. Marketing loves that because then they can say, we use agents in our solution. But for this discussion, let's define it as it's a component of a system that has a single specific goal or task to perform, and let's say in an LLM workflow, because otherwise it's just a function in a body of code. It's typically something that the LLM cannot do like search the web or access a database. And so, but within this definition, the LLM itself can be an agent, which is fine. Here at this point, we need an agent to review progress. Well, we would do that with the LLM rather than with web search or etc. Go back to the flowchart idea. So each node in a flowchart has a function. Some of these make decisions. Some of them call other functions with code elements. Some interact with external tools. And each of those, by our definition, would be an agent. So each of the nodes in your function is an agent. And that's fully analogous to agentic behavior with LLMs and can include reasoning LLMs now. So how's it analogous? Well, let's say you've got a reasoning LLM. You give it a high-level task. It breaks down it breaks it down into a plan, which is, as we've been saying, essentially a flowchart. So the reasoning models are creating a flowchart. That's actually a very reasonable way to think about it. You give it a big task, and it's got to figure out how to solve it. Maybe it's by asking questions, writing a spec, and then coding. Maybe it's more complicated. But the reasoning models come up with a flowchart. They might be able to do everything that's needed for each of those nodes, from decision making, task decomposition, etc. But they might have to call out to other functions to perform them. Search the web, retrieve data, perform a calculation. LLMs are not great at math, but that's changing. And those other functions can properly be called agents. You can write this up yourself. You can use LangGraph, et cetera, et cetera. And the calling out part is variously called tool use, function calling, or agentic behavior. Not a term that I think is very descriptive, but now you know what what it's supposed to mean. So agentic systems, if you don't have the reasoning models, in most cases, not always, but in most cases, you, the developer, would have to basically come up with a flowchart yourself. These are the different things that we have to do to solve this problem. Then write the code that controls the execution from scratch. You don't need to do that anymore. You can use a tool like LangChain. But one of the issues is that they are often not, it's not always, but often they're not general purpose. You might have to create a different agentic system for each problem or domain. So what I'm really interested to see in the future is marrying reasoning models with agents. So you can have the LLM build a flowchart and use the agents to execute it, or execute the parts that the LLM can't do. And one last thing, something that you can already do today without any extra work. It's now built into at least OpenAI and Google Gemini, is reasoning models that include a search agent. And that's very powerful because it allows the LLM to call out to the web, call out to a web search, and get information that is not pre-trained into its weights, which is all it can work with without this, including data that's more recent than its training cutoff date. The term that folks are using for this is deep research, and you can go out and use it today. For example, to sum up, reasoning models can plan, review, rewrite, compare. Essentially, they can think about thinking. That is the big piece of the puzzle that we were missing. And that enables us to tackle more complex, more important problems, which means we can generate products that have much more value for our users. And this opens the door for autonomy. Think about it. I worked interactively with chatbot, but if I turned it into an encapsulated product, I'd say, hey, do this for me. It would go out and do all the steps, ask me clarifying questions if it needed to, have me review the spec if it wanted me to, et cetera, et cetera. But essentially, without my interaction, it would be able to just take my first query and write the code. Very cool, but also problematic when these we've got to make sure that there's strong alignment with what we want these systems to do when they become autonomous. And just as a last postscript here, I said that there are reasoning models that are coming out every day. A new one that came out just a couple of days ago, very highly rated, called Gemini 2.5 Pro Experimental 0325. The only reason you need that is so that you can go, when you go to the AI studio, you can pick the right model. So go try it out in the Google AI Studio. It's free. You can start playing this and playing with this and figuring out what it can do, what it can't do, how you might be able to use it. There's a URL at the bottom here, and you don't actually really need that. You can just type into your web browser Google AI Studio, and it will find it. So thank you for your attention. This was a lot of information that I was throwing at you. I hope some of it was valuable. I hope this has given you some ideas of ways as product managers you can now use these new tools. And I'm available for any and all questions up to the end of time, and I'll hand it back over to Ida so she can manage that for us.
For sure. Thank you so much, Don. It was very insightful, very informative session. Thank you for
My
that.
pleasure.
For those of you who want to ask questions, if you're in Zoom, feel free to raise your hand or type it in the chat. I'll pick it up from the chat. If you're in LinkedIn, you could also put it in the chat and I will pick it up from the chat as well. We did get one question, Don, and it was, how do you differentiate yourself to your client given AI can do a lot of the workflows?
Ah, because as of today, um, there aren't a whole lot of people yet that know how to wrangle those workflows. So that's a really good way to differentiate it. Most of the clients that you're working with in industry are not super high tech. That's not true for everybody, but it's not like they could on their own um, go out and just build this product themselves. And even if they've got a very, very talented development team, which most of my clients really do, most of them are new to the AI world. So helping them get through their first AI project with helping them avoid the dragons that are hiding in this, because there's a lot of ways that you can, if you come from a standard software development background, there's a lot of ways that you can misunderstand the development approach. So helping them through their first product can be really, really valuable for your clients. I hope that was a reasonable answer. If not, ask a follow-up, and I'll be happy to give you a little bit more information.
Sure. We've got another question. Do you have skilled developers check code for anything that's not just MVP, that's for real production? What about deployment?
Oh, absolutely, absolutely. Important rule is at this point in the development of AI, absolutely you want a human in the loop, if not at every step, at each of the key steps. And I would still do all the QA by hand. I won't say by hand. I have people still doing all the QA. They may be using AI tools, but they are the ones responsible for all of QA engineering, whichever tools they are using. So absolutely, make sure you always have a human in the loop, at least at the important steps.
You got a thumbs up on that answer.
Good.
Again, if anybody else has any questions, you can throw them in the chat. I'll pick it up there. Otherwise, if you want to just go ahead and ask your question on Zoom as well. It seems like, oh, we've got one. When shopping around for models, how do I know which support reasoning?
Oh, okay. A couple of really important concepts here. Um, First of all, shopping around for models. That is a key step that people leave out. My last project, the insurance domain, I evaluated 11 models for the customer before we picked one. Um, all models are not created equal. They're trained differently. They're trained on pretty much on the same data, but trained different ways on that data. So that's very, very much an important thing to do. Don't just say, hey, I love this model. I'm going to use it for this product. And beware, the one that you pick for your first project is likely not going to be the one that you pick for the second project. Different domains, you need to reevaluate them. But how do you pick the ones that have reasoning capabilities? Right now, it's really easy because they all have that in their name, or it's a mode that you can pick in when you're using it as a chatbot. And it's also a mode that you can pick in the API. In fact, some of these allow you to set the threshold. How much reasoning do you want this to do? I had things set on max for what I showed you today, so it wrote multi-page specs. You can select whether you wanted to just do an answer by rote, or you can, or a little bit of reasoning, full board reasoning, etc. So finding them is easy, and you can even control how much reasoning they do.
Question is, do you have experience deploying an agentic system with a reasoning model?
No, not yet. That's on my list. Great question. Yeah. How much fun is that going to be, right? It's instead of having to build the quote flow chart, I'll let it do it. And yeah, I have not done that yet, but it's something that absolutely is coming.
Interesting. Um, do you think that they're going to be industry specific battle of the models? That is, small language models that are better in specific domains, or does reasoning require a lot larger token space model?
A couple of questions in there. Reasoning does require more tokens because each of the reasoning steps is ingesting and producing output. So you need tokens for that. But the context windows are getting pretty big. I mean, Gemini is up to 2 million now. Um, and small language models that are better in specific domains. It's very hard to predict the future in this in a field that's moving this quickly. But with all the stories about DeepSeek R1 and such, and how you can maybe do this with less compute or with smaller models, I'm expecting to see. Whereas now the big AI solutions are being built for the big industries and the big companies. I'm expecting to see medium and small sized businesses um, uh, uh, either building or somebody is building and selling to them very specific domain specific models that they can run economically to solve their particular problems. We'll see, but I think it's not unreasonable to expect that.
Thank you. We've got a couple more questions. So here's one of them. What's your typical evaluation criteria when picking a reasoning model? What are things you look for?
Yeah, this is very subjective. Any type of one of the things that's really, really hard to do when you're working with language models is create quantitative metrics. A lot of it is very subjective and qualitative, which is unfortunate because we like to be able to measure things to measure success and to measure progress and declare success. But it depends on the domain. In the insurance domain, for example, one of the things that was really important was since most of the users are just going to be people like you and me that aren't from the insurance industry, and insurance policies have all this legalistic language, it was a model that can do a really good job explaining uh, the weird terms of art from this industry and being able to say, well, what's a rider? What is a disclosure page? And being able to express that very easily and simply. That was really important. There were a number of different categories like that. But in the end, it's still very subjective. So I wrote up, I actually used uh, um, I forget what it is. There's a tool in Google that lets you Google surveys. Basically, I wrote up Google surveys and a bunch of Google survey things and said, for this question, here are some of the top answers that I have. Tell me which you think are the best, and sent that to my clients so they could evaluate it. And from there we could figure out which model they thought was best for their domain.
Thank you. All right, we've got a couple more questions. Hopefully we'll have time. Do you have a recommendation or favorite framework for building agents, specifically for enterprise grade?
I don't. I know there are a lot out there, and I see other people evaluating them online and listen to them, but I don't have a recommended favorite framework. But I suggest that I suspect that if we go to the agent framework workshop that Ida is putting together, we're going to learn a lot about that. So I can't give you a personal a recommendation, but there are lots of ways to get that information.
Absolutely. Our course will teach you how to build no-code AI agents, and would love to have you.
Yes.
Anybody would love to join. Okay, if we have time for one final question, sorry, this is a question I've actually heard a little bit in these sessions, and the question is sort of especially for product managers trying to incorporate AI into their products in terms of building a business case. The question is, you touched on convincing your executives to fund these projects. Can you expand on how to best build and present the business justification or case?
This is such an important question, Kristen. Thank you so much for asking it. That would take another whole hour in itself. But the important thing is to convince them that you have done your due diligence, that you know how much projects like this might cost, what the added value will be. And the other thing that's really important, and I'm finding this with a lot of my clients, they say, well, we want to do XYZ, help us do XYZ. And here's some ideas that the developers have come up with. And developers are smart, curious people. They want to learn everything they can about AI and expand their skill set. And they've got suggestions like, well, we're going to use RAG and we're going to fine tune and we're going to use agents. And in a lot of cases, you don't need some of those things. You should really, really, really do your homework before you suggest that there's any type of fine tuning involved. And I can back that up, but not in a few minutes that we have. Likewise, RAG. You should only use RAG when there's no better way to do it, and that basically is when you've got a huge corpus of documents, and you have to pick the right one out of thousands or tens of thousands. If you can show your leadership that you've done your homework, that you say, blah 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 blah, we don't need to fine tune. That will save us months and months and months in the schedule and a whole lot of money. But our particular situation really calls for agentic behavior, and here are the options. Um, you know, that is a way to make them feel more comfortable about what you're proposing. I would hesitate from giving an exact number. They're going to push you to do that. Maybe give a range if you have to, because, like I said, a lot of this development is experimental. It's trial and error. It's very hard to determine in advance how long it's going to take. But if you make it clear to the executives that this is a schedule that's going to be a little bit fuzzy. There's some things that have high risk in it. We're going to try and squeeze out all of the risk as early as possible in the development schedule as we can, so that we don't come up to some dead ends or to some big unfortunate surprises toward the end. So again, just to summarize, do your due diligence, show them that you've done your due diligence. Don't be like a kid in the candy store. Oh, we need to do this, we need to do that, we need to do this other thing. Show what you need, and actually, it's valuable to show why you don't think we need X, Y, Z.
Thank you, Don. I suspect we might need a separate session on that. But Kristen also gave you a thumbs up. So thank you so much for the presentation. Thank you for taking the time. Thank you for answering our community's questions. We will be posting the video on our website. Stay tuned for it. And I also want to remind everybody, next April the 18th, we've got a presentation on AI cybersecurity for product managers. That one's pretty exciting. We'd love to have you all there. And just a reminder again that we've got AI agents course starting next week, April 1st. And if you want to become an AI product manager, join our 5-week course. Pretty intensive. Starts April 28th, the week of April 28th. Thank you so much again, Don. Really appreciate you coming
You're,
out here and spending the
you're
time.
welcome.
And
My
thank you for
pleasure. I hope it
all.
was useful.
Absolutely. Thank you so much. Thank you, everybody. Enjoy your weekend. And please answer the survey as well and let us know what you think. Bye.
So hi there, my name is Kevin. I am a product manager at a company called Vicasta. Really, I've had some exposure to AI and ML products in my professional life, and really I joined the AI ML cohort to get a better understanding of like the end-to-end AI ML product development cycle. So yeah, I really appreciate the cohort. It's helped me a lot in product decision making, and yeah, much appreciated.